Want to see how we got from this to this?
Keep watching this video to learn about how we reduced our material consumption by avoiding cement concrete, plastic and chemical wood protection to create a highly sustainable green roof.
Yeah, I think that's it.
Roofs make up a huge part of our urban landscape, and this rarely utilised space contributes to the loss of biodiversity and overall unsustainable nature of cities. When we began the process of renovating our workshop, we had to address the challenge of covering our 140 square metre roof. In our mission to adopt low-tech, sustainable architecture and construction techniques, we embarked on the journey of researching, designing and building a green roof for our workshop in Porto.
Green roofs are by no means a new concept, having existed throughout the history of human settlements. However, in the last decades, this technology has gained a new popularity for its promising answer to the problems incurred by an urban environment, such as pollution, water retention, density and quality of buildings, energy efficiency and loss of biodiversity. Some noticeable arguments demonstrate the need to consider green roofs as a valuable system to at least partially resolve those issues. Its vegetation and layer composition creates a system that improves quality of life in the city by delaying peak floods while retaining rainwater, reducing CO2 while producing oxygen, and recreating biodiversity.
With all these claims, we must keep in mind that green roofs are by no means a fix-all solution to the problems incurred by continual growth and development. They must not be taken as an afterthought or used as tokenism for a new concrete and steel skyscraper. The idea of sustainable development in the global north must be challenged for the greenwashing that it is. To truly merit the sustainable features of a green roof, it should be incorporated into an ongoing process of decarbonised construction that focuses on renovation and restoration of existing buildings and structures.
In previous videos and articles, we have covered the methods we use for building the structure of our green roof, incorporating tire foundations, rebuilding and reinforcing stone walls, and using the methods of yakisugi to preserve wooden structures. All of these techniques allow us to avoid the extremely polluting and unsustainable material that is cement concrete.
The impact on our environment caused by the cement industry by building with concrete is enormous. The production of cement is a high energy consuming process. This energy is mainly obtained from fossil fuels or by burning waste. In addition, the chemical process of producing cement releases 1 molecule of carbon dioxide per each molecule of calcium silicate hydrate.
For each ton of produced cement, 1 ton of CO2 is emitted just by chemically processing it. Besides the vast amount of carbon dioxide emitted, many other hazardous air pollutants such as NOx and PM10 are emitted during the process. Staggeringly, cement concrete production accounts for 13% of global CO2 emission.
So for the past 5 years, we have been dedicated to exploring alternative solutions to achieve truly sustainable architecture and construction practices. We focus on the low-tech, accessible solutions which can be adopted by the many. With this philosophy in mind, we were very excited when we were presented with the opportunity to collaborate with Neoturf, a Portuguese company dedicated to creating green roofs and green spaces that contribute to the sustainable transition of our cities.
They are conducting research on the development of eco-materials and sustainable construction techniques for green roofs. Their research investigates the use of industrial inorganic and organic residues as the growth substrate and drainage solutions in urban green roofs. If the research proves a success, that method would put the technology of green roofs at a new level of sustainability and circularity.
Moreover, they are future-proofing green roof technologies as they anticipate future regulations to require new constructions to use recycled materials. If all goes well, this could offer a turning point in the history of green roofs.
Our research of modern green roofs found that the material used in construction did not align with the sustainability ethos that green roof proclaims. We sought to find alternatives to plastic filters, insulation, and drainage systems.
These are the materials that typically make up the layers of the green roof. As you can see, there are many different components and materials. We wanted to simplify this to reduce the material consumption and make it as easy to replicate and apply in other situations as possible.
So let's take a look at the design solutions we came up with and explain the components and their mechanism that work together to create a highly functional, environmentally friendly and circular green roof.
First off, the EPDM layer covers the OSB boards in a waterproof layer that will prevent the moisture from reaching the wooden structure below. EPDM was the best option for us at this time due to the availability and long lifespan.
As our design evolved from the initial plans in 2018, we realized we needed to make slight adjustments of placing small risers under the EPDM for the wood barrier to rest on and allow water to flow underneath to drain away. We cut the EPDM, placed the risers and scaled it back up with 2 additional layers of EPDM and silicone. This will ensure the roof won't be susceptible to water infiltration when we screw the wooden boards into the roof.
Next, the wooden barrier to support the earth was installed. These boards were charred using the inspiration from the Japanese technique of yakisugi. This offers protection from mould, termites, fire and water. We used a modified rocket stove to achieve this efficiently and sustainably. You can see more about this fascinating technique on our other video here. Additionally, the wood was treated with cooked linseed oil to offer more protection from the elements by counterbalancing the loss of humidity and flexibility from the burning process.
Now, the cutting edge of our green roof are these cork insulations and the drainage boards. This is the first time the design and technology has been implemented on a green roof of this size, so we are very excited and hopeful for the results. We first learned of this research from LabLab, who puts us in contact with Neoturf, who were facilitating the research. The expanded cork is a byproduct of the industrial process for manufacturing corks. In our mission to use as many nature-based materials as possible, we were delighted to find this solution.
These corkboards have a dual action of providing insulation with a thermal efficiency of lambda 0.038 to 0.04 watts per metre Kelvin, or R3.6 per inch, which is comparable to materials from synthetic sources such as expanded polystyrene.
Additionally, this grid has been meticulously designed to allow for a high flow of water drainage, something which is much needed for a roof to withstand Porto's frequent torrential downpours. By using the design and materials, we negate the need for synthetic insulation, plastic drainage cups, and other plastic liners.
To protect the cork from the plant roots and the substrate, a geotextile layer is needed. This prevents silt and other particles from the substrate from clogging the grid drainage system within the cork. Activated clay balls surround the borders of the walls, windows and wooden barriers. These provide additional drainage and fire protection.
Beautiful.
100% recycled material is used for 2 of the 4 substrate types. The other one uses 1 added product from commercial sources, and the final substrate is the commercially available substrate that is used as the current industry standard in green roof construction. Neoturf's research over the next 2 years will explore how well the other 3 substrates perform compared to the industry standards.
Typically, for our climate and size of roof, no additional irrigation systems are needed. However, as we want the perfect conditions for this research project to take place under, a water irrigation system was installed. In the near future, we will build a rainwater harvesting system and use this water as a source of irrigation.
The plants used in this project include sedum, grasses, thyme and others. The use of these plants are already well established in green roofs construction and promote biodiversity in a small area compared to planting a monoculture lawn.
And there we have it, our green roof is finally complete after 2 intense years of research, structural preparation and finally implementation of the green roof. It has been a monumental effort to get here and many people have had a hand in the various stages of this project.
The next step for us are to install a rainwater collection system to provide water for the irrigation system, thus closing the circle of resource use. Neoturf research will continue for the next 2 years, where they will come monthly to take measurements of the growth of the plants in the different substrates. Thereafter, we hope to plant crops to provide us with the sum of our own food source.
Thanks for watching this video, and make sure to check out our other videos on sustainable architecture and construction, and subscribe to make sure you don't miss our new videos.
Ciao!
Ciao!
Critical grade.